Welcome to this explainer. Today, we're going to completely crack open the .claude folder. Look, if you've been using Claude Code, you've definitely seen this little folder pop up in your project root. And if you're like most devs, you've probably treated it like a total black box, maybe even steering clear of it entirely so you don't accidentally break something, right? You know, it's there, but you haven't really touched it. Well, using Akshay Pashar's incredibly comprehensive guide, we're going to transform that ignored folder into your ultimate, highly customized AI control center. Because honestly, once you understand exactly what lives where and why, you can dial in the AI to behave exactly the way your team needs it to.
So here's our game plan for this anatomical tour. We'll start by opening that black box to understand the macro structure, then check out Claude's instruction manual. From there, we'll dive into enforcing behavior with hooks, deploying specialized skills in subagents, managing your permissions, and then we'll wrap the whole thing up with a practical, step-by-step setup guide.
All right, part one, opening the black box and mastering your AI's control center.
We need to start by understanding the macro structure, because, surprise, there isn't actually just one folder you need to worry about. There are two. On one side, you've got the project-level .claude folder. This one holds your team's configuration, so your shared rules, custom commands, and permission policies. All of this gets committed to Git, so everyone on the team is on the exact same page. But then, on the other side, you have the global folder sitting in your home directory. This one is strictly for your personal preferences and your machine local state, things like session history and auto memory. It keeps your personal quirks completely out of the shared repo, and that is huge, because it completely prevents that classic nightmare scenario of accidentally committing your messy, personal AI prompts into a pristine team codebase.
Let's move on to part two, Claude's instruction manual, or how to write the perfect claude.md. Let's look at how this builds your bedrock foundation. The single most important file in this whole system is claude.md. The second a session starts, this file is loaded straight into the system prompt. Now, notice the strict contrast here between what you absolutely should provide versus what you should leave on the cutting room floor. You definitely want to include build and test commands, key architectural decisions like saying, hey, we use a monorepo, and specific naming patterns. But you actively want to avoid dumping in linter configs, massive external documentation links, or long rambling paragraphs of programming theory. Basically, Claude doesn't need a textbook, it needs a cheat sheet. Which brings us to a really crucial point, and it's this number right here, 200. You really need to keep your claude.md under 200 lines. Why? Well, if it gets longer than that, it just eats up way too much context. And paradoxically, Claude's instruction adherence will actually start to drop. More instructions do not mean better results if they just dilute the focus. So keep it lean.
But you might be wondering, what happens when the project inevitably scales? When your team outgrows a single file, you level up to the rules folder. Instead of having one giant, completely unmaintainable 300-line markdown file, you modularize. You split the instructions by concern. So the person in charge of API conventions can edit one file, while the testing lead edits another. And it gets even better. You can use YAML front matter to create path-scoped rules. For instance, you can tell Claude to only load the API rules when it's actively editing files inside the source/API directory. It keeps the context window perfectly optimized for the actual task at hand, which saves you both tokens and time.
All right, part three, enforcing behavior with hooks, giving you deterministic control.
Because let's be real for a second. Instructions in Markdown are great, but they're really just suggestions. Claude's gonna follow them most of the time, but you probably don't want to bet your production database on most of the time, right? You can't always rely on a language model to magically remember to run your linter, or more importantly, to never ever execute a dangerous terminal command. So what exactly do you do when Claude strays from the rules?
The fix here is hooks. Hooks give you pure deterministic control. They're event handlers configured right in your settings.json that fire off your shell scripts automatically at very specific points. Every single time, no exceptions. And here's a brilliant little technical detail from Akshay's guide. They use exit codes to decide what happens next. Exit code 0 means success, but exit code 2, that is the magic number. It's the only code that actually blocks execution. A really common trap is using exit code 1 for security hooks, which honestly just logs an error and does absolutely nothing to stop the AI. You need exit code 2 to stop everything cold and force Claude to self-correct. You can attach these hooks to specific events to build a bulletproof workflow. Pre-tool use acts as an absolute security firewall before a tool even gets to run, which is perfect for blocking dangerous bash commands. Then there's post-tool use, which is awesome for things like auto-formatting files with Prettier right after a successful edit. And then you've got the stop hook. Think of this as your quality gate. You can configure it so Claude literally cannot declare a task done until the test suite actually passes. A quick warning though, be careful with stop hooks. You have to check the stop hook active flag in the JSON payload, or you'll accidentally trap Claude in this infinite loop of trying to stop and getting rejected. Oh, and you can also use a notification hook to trigger desktop alerts on your Mac or Linux machine whenever a task wraps up, which is pretty sweet.
Moving right along to part 4, skills and sub-agent personas. This is where we unlock specialized workflows on demand. So with our safety gates firmly in place, we can start tapping into some truly advanced powers by checking out the skills and agents folders. Skills basically act as packaged, reusable workflows. Unlike basic single-file commands, skills bundle all the supporting documents right next to a skill.md file. And the really cool part? Claude can intuitively trigger these based purely on the context of your conversation. Just imagine saying, hey, review this pull request for security issues. Claude reads the skill descriptions, recognizes a match, and just automatically invokes the security review skill, pulling in all the necessary guidelines without you having to lift a finger.
For those really complex workflows, we introduce agents. I love this direct insight from Akshay's guide. When Claude needs a code review done, it spawns this agent in its own isolated context window. The agent does its work, compresses the findings, and reports back. By setting up specialized sub-agent personas in the agents folder, you completely declutter your main context window. You can even assign cheaper, faster models, like Haiku, to handle simple read-only exploration agents. That saves your heavy hitter models like Sonnet or Opus for the actual heavy lifting. It's just a wildly efficient way to scale up what the AI can do for you.
Part 5, managing permissions and settings. Let's talk about securing the workflow.
We've finally reached the file that acts as the ultimate gatekeeper for all these capabilities, settings.json. Inside this file, it's all about constructing a very careful balance. You've got your allow list, explicitly permitting safe operational commands to run without Claude constantly nagging you for confirmation. Stuff like read-only git commands, basic file edits, safe bash scripts. But conversely, your denial list strictly prohibits destructive actions. You absolutely want to deny commands like rm-rf, direct network calls like curl, or anything that could accidentally ruin your week, like letting it access your .env secrets. And if a command falls somewhere in the middle, Claude will safely pause and ask for your manual confirmation. It really is the perfect safety net.
Finally, part 6, your practical setup guide. Let's build this step by step. Okay, having explored all that theory, let's translate this into a concrete 5-step plan for your own code base. Step 1, simply run /init inside Claude Code to generate a starter claude.md and just edit it down to the essentials. Step 2, add your settings.json with those allow and deny rules we just talked about to establish strict safety boundaries. Step 3, create core commands for your most common workflows so you aren't typing out the exact same prompts every day. Step 4, as your project inevitably scales, split those crowded instructions out into the rules folder. Keep those context windows lean and laser-focused. And finally, step 5, add your global personal overrides in your home directory so your own unique coding style is preserved without messing up the shared team repo. I think this quote perfectly distills our entire explainer today. Akshay notes, the .cloud folder is really a protocol for telling Claude who you are, what your project does, and what rules it should follow. It's literally a dedicated communication protocol between your team and the AI. And the clearer you define that protocol, the less time you're going to spend babysitting the AI, and the more time it spends actually doing highly leveraged, useful work. Taking this infrastructure seriously pays dividends every single day. Look, you wouldn't leave your CI/CD pipeline completely unconfigured and just cross your fingers and hope for the best. So why on earth are you doing that with your AI? So what do you say? Are you ready to stop treating Claude like a black box and finally grab the steering wheel? Start small, configure your Bedrock rules today, and just watch your team's productivity absolutely soar. Thanks for learning with us on this explainer.